they compared it to New York City, how big it was.
Oh, yeah. Good Lord.
Yeah.
So can you imagine? Yeah. So we've angered it. Now it's going to change course. Like, who landed on me? Humans. Yeah.
I think you should go check out this new movie. It's called Interstellar. I think it's pretty.
Oh, really? Yeah, I've heard about it.
Yeah, it's actually pretty good.
Well, this is a little epic.
Yes, it was.
I don't know. All right. Yeah, I was definitely thinking I'd love to see that. I'm more a Guardians of the Galaxy kind of guy, but that's all right.
It's like calculus, man. You have to really pay attention.
Oh, no. Shoot. I hate that. Like Inception, I'll watch it again with a notebook. So I'm like, what the hell? Okay, I think they're on this level now. The train again. Shit. Yeah. All right, so 112 has let f of x equal 5x to the negative 1/3. When will f of x be greater than 0? So what do you think? How's this work? So what's another way? What's this really mean? Greater than 0. What's another way of saying if there's a number that's bigger than 0, we call it what kind of number? Positive. So really it's asking, when is this function going to be positive? Well, you can kind of turn around. What's the only time that this function would be negative, or can it be negative? What's the only time this function would be negative? When x is negative. What's happening to the x? What's happening to the x? How could I rewrite this? What's a negative mean? Flip it. So do I take the 5 down too? I probably gave it away with the way, but 5 is in the first power. It's happy where it is. It's positive, right? I'm only going to change people that don't like it, the negative people. So the 5 stays up here. This x, the 1/3 comes down, right? Because the negative power means flip. And what's a 1/3 power mean? Cube root. So I'm just kind of exploring what the hell that function is, what it really does to something. So the only way a cube root could be negative is if the number inside of it is negative. Now what do you notice? What can x not be, considering where it is?
0.
Yeah, if x were 0, this thing would be undefined, right? Can't divide by 0. So that's why they have this greater than 0. You can't really make it equal 0. But when is this positive then? If it's only negative when x is negative,
It will be positive if it's
it'll be positive when x is positive. That's right. So how do you say that? How do you say x positive? You can say x is positive. No, I don't want that. I want a mathematical solution. Don't give me English.
Is it equal or greater than
Can't equal 0, right?
greater?
Greater. Yeah, if that means positive, okay, I can use it. So when is the function positive? When the inputs are positive. Because if you put a negative number in there, it's going to become negative, right? What's the cube root of negative 27?
We're negative 3.
Yeah, the cube root of negative 27 is negative 3. Can't be 3 because 3 times 3 times 3 is not negative 27. So you need a negative in there, right? So if you try to put a negative 27 in, it won't work. It's not supposed to be negative. It's supposed to be positive, right? So you can only put positive values in. Okay. I like that question because you have to really tease out. It's got the function notation. It's got what the hell does this mean? It's got how the hell do I get that? It's got everything. Yes.
Cube root of the negative 27. Could you, how we just learned about the I, could you can't do that?
No, it's not that you can't. It's that you don't need to.
You don't need to?
The only time you need to use I is if it's an even root of negative.
Oh, okay.
Because this doesn't have a real answer. This has a real answer already. Okay?
So that would be a negative 1.
But today, there is something kind of related to what you're asking about. So our question was, square root of a negative 4, what would that be? What's square root of negative 4?
Absolute.
What is 2i?
2i. There you go. If the square root of 4 is 2, the square root of negative 4 is 2i. And again, to see it directly, you can break this up as square root of 4 times square root of negative 1. Square root of 4 is 2. That's defined to be I. But you don't need it for a cube root that's sitting there staring you in the face. But what we're going to learn today, if I said this, how many answers should there be?
3.
There should be 3. I think we talked a little bit about this every now and again. Is whatever the degree on the equation is, that's how many answers there should be. If I take a cube root of it, how many answers do I get? 1. So where the hell are the other 2 answers? So we'll talk about that today. We'll actually do that today. We'll figure out what the other 2 answers are. And they end up being complex. So I like your question. It kind of sideways to that question was this problem. Alright. Cool. Alright.
Sorry.
Alright. Eyes inside that. Is there anything else from homework? Anything else from homework? You guys doing homework?
I haven't. I don't know where is it.
One of them was just I to the 20th,
Okay.
and it was fine. I think, yeah, it was like that. And then
So
I
what's
did
the
all-
shortcut for this? Every how many?
4.
Every 4 of them comes back to...
They broke it down like
1.
2 to 10, and I was like, what?
You could do that too. There's a lot of different ways. So I would do it like this. I to the 4 times 5.
Okay.
And then that's going to be... I mean, you could do I to the 4th to the 5th. Is that cool? You see that? Because what would you do with these powers? So that is the same thing as this, isn't it? It was I to the 4th.
1.
And 1 to the 5th is 1. 1 to any power is 1, right? But you could also say this is I squared to the 10th power. Isn't that still 20? And what's I squared? That's the most important one, right? Negative 1. And what's negative 1 to an even power? If I have an even number of negatives, you get positive 1 either way you do this. To me, it's better just to relate it to the number of 4s.
Yeah, I like that.
Finally, my way's easy. This whole semester, my way's been the worst in every class. I don't like your way, Joe. All right, fine. Just do it some other way. It's okay.
I was trying to understand your way.
But I've seen people do it this way. I mean, whatever way makes more sense, that's the way you do it. Since there are a lot of different ways to do it. Pick the way that makes the most sense. But if I had maybe Roman numerals are good. If I had just to remind us, if I had this, how would I do that?
Every 4.
You know the
47
short
divided by
ones.
4. And the
I
closest
remember the
number.
chart, but that's not it.
Within and whatever's left over?
Exactly. So 4 goes into 47
11 times.
with how many left over?
3.
So you could do this I-44, I-3.
That's the final answer.
No. And the final
And the
answer
three
is
is
I to
like
the
that.
3 is negative.
This is going to be 1. But to me, I don't even like this. I just like doing what we just said. 4 goes into 47, 11, remainder 3. So I know I'm the third one in the cycle. You just got to remember what the cycle is. I1 is I squared is, I cubed is, I4 is 1. So I'm the third in the cycle. The answer is
Negative I.
negative I.
So it's really like I1, but you just have to remember that.
Yeah, I just remember the first one in the cycle is I. And then the second one is negative 1, so forth. So if I had remainder 1, the answer is I. If I had remainder 2, the answer is negative 1, so forth. If I have remainder 0, and to be honest, I to the 4th is 1, but it might even make more sense if you say I to the 0 is 1. So if you have no remainder, it's 1. Remainder 1, it's I, so forth.
So it goes back.
It's just because it's cyclical. Even if you don't really understand that, the most important thing, of course, like I keep saying, is that. Because that's what occurs the most. So before we FOIL something get x squared, it just has to stay x squared. We don't know what the hell x squared is. But we know what the hell I squared is. So now when I FOIL a complex number out, you've got to go further. Because you know what that is. Okay, cool.
Hey, Jeff, I have a question about the math lab. Made me do, when I was foiling some of that stuff, it made me do like break it up into 2 different fractions. Like something over 78, something over 70, plus something over 78, and then with I.
Oh yeah, so we talked about that a little bit.
If I just do like 14 plus something over the 1.
Yeah, I told you that was fine.
Okay.
But remember, a little review here. How do I do that division?
Yeah, do the cheating error, whatever it's called.
The,
I minus 3.
What is it
Right,
called?
right.
Yeah, multiply by I minus 3.
The cheating arrow.
What is it called?
Yes.
Oh, the conjugate.
Conjugate, yeah.
All right, I
Cheating
thought it was some new superhero show. I'm the cheating arrow. You cannot trust.
That's Spanish kind of encompasses everything.
Yes, that's the conjugate. So on the top you get, I'll do the top. On the bottom,
I minus 3.
you get I squared, which is
Minus 9.
-1, minus 9. So you get I minus 3 over -10. So I said it's okay to leave it there. But in reality, you should be able to break it back up. So you see A plus BI. Just kind of backwards there, right? So cool. You should always be able to write it as A plus BI.
On the computer, wants A plus B I.
Okay, gotcha.
They're very literal.
No, it's a good idea. It's because it kind of completes. If you start with complex numbers, you have to end with complex numbers. You can't suddenly make something new out of it, no matter how hard you try. Okay. Anything else from homework or general ideas? Okay. All right. So last time we did completing the square, and the last thing we did was just talk a little bit about quadratic formula. So I'm going to show you, and I told you, I promised you this, I'm going to show you where quadratic formula comes from. If I were you, just leave my pencil down. It's in the book somewhere in chapter 13. Anyway, so the whole idea behind quadratic formula is to solve that. Now, the way we were doing it last time was by completing the square. Does that ring a bell? Right? Okay. So the way we solved, so last time we had like x squared plus 10x minus 2. We moved the 2 over. We took half of 10, squared it, that kind of stuff. Remember that? So the way we do this is, and you'll love this so much, we do that same thing to this directly, with no numbers in it. Right? That's how we develop formulas in general, is to say A could be whatever number you want it to be, B, so forth. So do you remember what we had to do if the first number was not a 1?
Multiply.
I'm not factoring now. I'm using completing the square.
A number greater than 1?
No, I'm not factoring. So let's remember this. Let's see. So if I had 2x squared plus 6x minus 1 equals 0.
You cut the 2 in half, don't you? Cut the 2 in half.
Yeah, I would move that 1 over and then divide by 2. Because the first number has got to be a 1 for completing the square to work. So what's my first step on this problem?
Divide by 8.
Divide by 8. I love it. So I know that you guys are almost immediately turned off, and I'm not speaking for everybody, but most of you guys are immediately turned off when you see no numbers anywhere, except the one little square dude. That's not much of a help. But the beautiful thing about completing the square, the process, is it almost doesn't matter how ugly the thing is you're working with. It's just always the same. Take half of it and square it. And bam, put it in there, and it tells you how to factor the damn thing. So here's the ultimate ugliness. This is as ugly as it could be. So I have to divide by A. I know I have to because I got to divide if there's a number out front. So then I get x squared plus b over ax plus c over a equals 0. How are we doing so far? Now comes the exciting part. What do I want to do with this? Yeah, I want to get it out of the way, right? Just like I would that 1.
So we're just solving for A or for X?
We're solving for x, exactly.
For X.
Yes. I like the way you make it sound like it's no big deal. It is a big deal because these are not the same degree, right? So it gets a little bit weird. So you move the c over a out of the way. Make some room. Right, because the first thing we do here is move that 1 over, make some room here. Because I got to have room there so I can put the answer to my little 2-step process, right? Cut in half and then square it. So there you go. I just told you the next steps. What do you do next? Yeah, take the middle guy. Now, don't write b over a over 2. How do you cut something in half? You take half of it. So what do you get?
B over 2A.
Beautiful. b over 2a. That is half of b over a. So if the middle number is a fraction, you write your 1/2 as a fraction. You don't make it as over 2 because that doesn't look as easy. Make it 1/2 and then you just got to multiply straight across. Yeah, you guys love this, I can tell. And what's your second step on the little? Square what you get. Now if you know quadratic formula, this should start looking a little bit familiar. So what do I do with this?
Once you plug that into that.
Now let's do this. Let's kind of run this along at the same time. Sorry. So you just got numbers in it.
But I have a question. Would it be 4A squared?
Oh, square, yeah.
Yeah.
Okay. Let me know when I do that.
You do the square root?
No.
You plug it in.
Here, what would you do? You would take 3/2 and then you would square it. And what would I do with this?
The 9/4 goes up there and then the 3.
Yeah, so this b over squared over 4a squared goes here. And if I add it here,
Add it to
You
the
have
other
to add
side
it to the
too.
other
I
side.
have to add it to the other side.
A
Squared. What am I doing, sir? What is that? I just don't want this to work. Now again, if you're writing this down, stop. There's no point. It's in the book. We're proving where this comes from. You never have to do this yourself. It looks ugly as hell, but it's really, all I've done is I had to get rid of the a. Then I took half of the middle dude and squared him and put him there. I haven't actually even had to think much about this yet. Right? This process is telling me how to do this. Now comes the part where you think it's kind of freaky, but it's not. I already know how to factor this guy. The first step tells me how to factor him, right?
Mm-hmm.
So this will be x plus b over 2a squared equals that business. Let me put that up there. Let me take him out. Okay, right, what we got here? We got, oops, I forgot this. Let me remember this. Oh, where are we? Okay, so now we got x plus b over 2a, because that first step on this always tells you how it's going to factor on the next step, right? Equals, let me write like this, b squared over 4a squared minus c over a. Now what can I do on this side here?
Have the same denominator.
I can get the same denominator, right? Yeah.
Multiply for 4A.
I like it. So this guy needs a 4 and an a. So I get b squared minus 4ac all over 4a squared equals this beautiful thing here, right? And then, of course, what do I do?
You put the
The whole reason I wanted to get it in this form was so that I can kill this directly by taking a square root. I like it. So square root, the minute I square root,
so 2 goes plus minus.
plus minus. Alright, so then, yeah, you're right, these go away. So you get x plus b over 2a equals, what's the square root of 4a squared?
2AB.
Now be careful, I can't do the square root of b squared because it's involved in a subtraction problem. I can't distribute a square root across subtraction.
One of the a's away.
I can't cancel these a's because two reasons. It's in the square root and this doesn't have a square root on it, so I can't do that, right? But this should look remarkably familiar.
Yeah.
This is it. Subtract it over and you got x, and they have already LCD, don't they?
That's still on it. I'm so sorry.
So you subtract it over. And you get that. So that is it. We knew that wasn't it yet, Arby, because we didn't have x by itself yet. We're trying to solve this thing, yeah.
And there's any way to check like the answer or something?
Yeah, you plug it in. there's no way to check this answer except to do some problems and make sure it comes out with the right answers. Right? But we did, and we applied what we've done before for specific problems where they told me what A, B, and C were. We just did it for an infinite number, every problem. Don't tell me what A, B, and C is yet. Let me work it out first. So that's why using quadratic formula normally is quicker, because all this complete square work has already been done to get there, right? So let's do a problem. Let's do it completing the square, and then we'll do it quadratic formula, just to make sure it comes out the same. And let me see. I think this is...
This set that bigger for teaching math.
do they do this in here? Shoot. Do they? Oh yeah, it's 13.2. This is on page 810, this whole thing here.
Is it on my math lab if you don't have the book?
You have the book in my math lab, so yes, it is. Page 810.
Was it 13.2?
13.2, yes. Alright, so let's try on that. So let's do completing the square first.
Yes.
So let's do, what you got, Jeff? 3x squared minus 12x plus 5.
Divide by 3.
Cool. Alright, so
We're going to do with the formula or?
yeah, we're completing the square first, and then we're going to use quadratic formula and see if they're the same. If they're not the same, we can't trust something. So, yeah, divide by 3, that's fine. And I can move that over at the same time here. Is that cool? So you definitely need the first number to be a 1. You definitely need to make some room at the end. Yes, sir?
When specifically you use the quadratic formula? When you decide? We get
We'll talk about that here in a minute. I'm going to put it all together here in a minute, yeah.
Hey, like before when we were figuring out fractions and we came up with the same bottom denominator, it would just kind of like wipe the whole thing out. And we'd just be dealing with the one equation. But
No, I didn't start with fractions. I divided by 3 because I don't want that 3 there. And then everybody else is divided by 3 also. If I multiply everything by 3, I would kill the fraction, but then I'd be back at the same problem I had before. I need this to be a 1. So I need that to be a 1, so I have to divide by 3. It doesn't go into 5, too damn bad. We had to divide by 3. Completing square won't work unless this number is 1. Is that cool? Alright, so how do I do this? What are the 2 steps?
Cut or now back 2.
Negative 4 over 2 is negative 2.
And put negative 2x.
Negative 2 squared is 4.
Is that negative 2x? 1 to x.
What's up? What's negative 2?
Yeah, that's
You have x squared minus 4x. So you put the 4 in half. We have to see where's the x at?
No, we're looking at the coefficients.
Oh,
Yeah.
okay.
Yeah, the x's are just there. It's the numbers in front that I'm curious about.
Okay.
X's I already know they're there. Who cares about them? I need to know what the numbers have to be. So what goes here?
4.
Yeah, this guy goes here. And
On the other side.
there. Good.
Minus.
If I add the 4 there, I better add the 4 to the other side, right? That's really easy to forget. But whatever you do on one side, you got to do the other side. Yes, sir?
on your little I example there.
Yeah, okay.
You got negative 4 over 2. Where do you come up with that 2 at?
Because there's 2 steps to do completed square are cut the middle, do it in half.
Oh, so that's all you do is cut it in half. I think you do.
Yep, cut it in half and then
put a 3.
square. Huh?
If it's 6, you put a 3.
No, you cut it in half. It was 6, I would put over 2 is 3, yeah. Is that what you're saying?
Yeah,
I thought you asked me where that 2 came from.
I was, but
Okay,
You would say, for example.
so this is always 2. You cut it in half, whatever the hell it is.
Right.
Even when it was B over A, we cut it in half.
And then after you cut it in half, then you take what your answer is, move down to your next step.
You square it.
You square.
So this step tells me what has to go here, and this step tells me how this factors, right?
Okay.
So how does this factor?
those kind of LCD.
X minus 2 squared. So this side factors like this. And like Arby said, the next thing I want to do is add those together. So of course I do need
Common
LCD.
denominator.
Yeah?
3, 12,
Yeah, so you get 12 minus 5,
7.
7.
And now
Again.
do square root.
Yep, so now we're at the stop. This is the whole reason we do this is so I can get something squared so I can just square root it and get
And
rid
you
of
do
it
the plus
directly.
and minus.
Square root, I like it. Plus or minus. So you get x minus 2 equals plus or minus square root 7 over 3.
So it's
And then you get rid of the 2.
Yep, add 2. So you get x equals 2 plus or minus square root of 7 over 3.
Let's do a test on that right now. Do that way.
Yeah, let's do it. So tell me, what's, so to try to use the quadratic formula, you have to know what A, B, and C are. So what are A, B, and C for this problem?
3 minus 12. And
Yeah, so A is 3, B is negative 12, C is 5. So one nice thing about quadratic formula is it's built in that the first number could be A, it could be anything. So you don't have to make this a 1, you could just use it. That's what A is. It's,
I have one quick question. Just, how did you get to the x minus 2 at the end? Right towards the end, that's just the only question.
are you cool from here to here?
Yeah, that's the only little thing where you came up with x minus 2. That's the only question I have.
So how do you factor this?
Oh, wow. Okay.
Yeah, and plus, you don't even have to factor it. That's just what's going to go in there. It tells you how to factor it.
Okay.
Yeah.
The first answer, right? Like the first answer showing you where to go. Yeah.
The first step tells you what's going to go in here, and the second step tells you what's going to have to go there. Yeah.
If you get 21, if we put 21, like instead of 7.
How? Oh, so you're trying to rationalize that. Well, I'm getting there. We're going to see we're going to have to do that here in a minute.
Okay.
But I like that you brought it up. Okay, all right. So let me do this. I'm going to pull this result up here, and then we're going to work from it. And yes, if you don't have that memorized yet, you have to have it memorized. Quadratic formula. Of course, when you don't see now, that's all I'll remember. How you doing today, Jen? Negative B, brush your eyes. I joke, but that's probably going to happen to me. So now you just plug and shut, right? Now it's just plug and shut. So what do you do? What's this negative what?
Negative
12.
No?
Negative.
Negative 12, right? B is negative 12. You with me?
Positive.
So that will become positive, right? It's the opposite of B. Plus or minus. Square root. What's B squared?
So
Yeah, true. All right. 144, thank you. So that B squared is never going to be negative because you're squaring a real number. It's going to always come out positive. I always get people that think it's this, and they get negative 144. No, you got to square the whole B. So you should get 144 minus 4 times
5.
what's up over there? So 4 A C. Cool. Okay. All over. Whole damn thing is over 6. Twice 3 is 6. Cool. So I get 12. Give or take, what do I have in here? 144 minus 60. Careful, can I cancel these down? No, not yet. Not if I'm not careful about it, because if the 6 can't go away, it's both of these are being divided by 6. So I'm going to do that at the end. So what do I have in here?
84.
Become a minus there. Now can I simplify rad 84?
No.
Yeah, we can break it.
Yes.
Of course you can. What's the most obvious thing that goes into 84 that's square rootable? 4. So this will be 12 plus or minus.
4, 2.
Yeah, square root of 4 is 2. And you're left with 4 times what is 84? Alright, let me do this. Okay. So square root of 84 is square root of 4 times square root of 21, right? Yeah.
Yes.
So then square root of 84 is 2 square root of 21. Now the only thing I can really do, especially if I want to make it look like this, I want to break them up. So this will be, 12 over 6 plus or minus 2 rad 21 over 6. 12 over 6 is
2.
Yay, that looks good. Right? 12 over 6 is 2 plus or minus. What happens here?
You leave that.
2 divided by 6, I can reduce to
1/3.
Yeah, so it's rad 21 over 3. Is that this?
Well,
Yeah, it is.
10, yeah. Well, it's 10, yeah. 7.
So then it's easier.
Are you ready? You ready? These are supposed to be the same answer. If they aren't, we can throw the whole damn thing out and move on. Right?
Can you?
So either one is.
Either one is fine, right?
Yes, but let me prove to everybody that that's true. Yeah.
Can you explain how this is divided order? You said why is it possible here to get?
Separating them.
Yeah.
Why did you separate?
If I had this, can't I put them together? Because they're both over 6, right? So all I did was went backwards. I said, all right, I can break them up as long as it's 12 over 6 plus or minus that over 6. I just went backwards. If I can combine two fractions, I can pull them apart.
Oh, you put them apart and then you simplify.
And then I simplify.
Okay.
Yeah, because now I have 12 over 6. That's 2. I got nobody else to have to worry about anymore, right? 12 moved out. It's on his own. Got cut down by 6 right when he moved out. And then this guy, he can reduce 2. Now to make you realize that those are the same numbers, this is square root of 7 over square root of 3. How do you rationalize this? What does he need on the bottom?
3.
He needs another 3, so square root of 3. So you get 2 plus or minus square root of 21 over 3. Same thing. So if you're worried that you got the wrong answer, because maybe the back of the book has it in a certain form, they just might have it in a different form than what you did. Maybe they are the same number. Maybe you just have to rationalize. Or maybe they just have to rationalize. I don't know. Okay. So let me give you this. Now we are at this point here. This is kind of a general, all the different ways we know to solve quadratic equations. All in one little sheet. It's on the... No. It's on the, what do you call it? The homework sheet. You have the homework sheet?
Yeah.
There you go.
Going back.
Good. All right. So the first way we learned how to solve quadratic equations was just by factoring. So somebody had a question up here. When do I use quadratic formula whenever you are unable to factor something? To be completely honest, completing the square of that method is rarely ever actually used to solve something like this. We use it to prove quadratic formula, and then we just use quadratic formula, right? So I could use it individually on every single problem, or I can prove quadratic formula once and then forever use that. Now, please, dear God, this does not mean you use this every damn where, right? You factor when you can, you use this when you can't, right? That's the idea. Because factoring, it definitely has uses every
So
day.
we use that one instead of that one?
Yeah, in fact, I want you to realize when we use this, we are completing the square. It's just kind of been done already, right? This is completing the square. It's just the form that it would take if I did it already. So these are the same method, it's just that there's less work here because I've already completed the square.
So we can do either method at all times.
So on it, you know what I'm going to do. So make sure you can do both. On a test, I'm going to say, solve using completing square. And then later I'll say, solve using quadratic formula.
Oh,
So then you have to, but in general, if I just said solve it,
You
We
can
can
use
use,
both.
you can use whatever makes the most sense.
and in the test you said you're gonna put one quadratic and the other one what?
Including the square.
completely square.
I won't say I'm going to put one, but I will say I'll have at least one problem where I tell you exactly what to do. So I make sure you can do it both ways.
And we can have like 3 days.
Okay. So let's talk about x cubed equals 27. Finally, we're going to get all 3 answers to this. The real answer is easy. What's the real answer? 3. You cube 3 to get 27. Where the hell would the other 2 answers come from?
Imaginary one.
But how would I get there? So the biggest mistake I saw with a problem like this is somebody would tell me the answer was that. Why is the answer not just that?
Because it's positive
So
and negative.
negative.
Why is it plus or minus?
Because you can have a -2 and be square.
So a more direct way to do this problem is to subtract the 4 over and then factor it, and you see both answers, right?
Oh, yeah.
All right, there. Do the same thing, right? Do it. Subtract the 27. Factor it. Do what? So subtract the 27 over. You get a cubes, right? Big dude, little dude. So factor that bad boy. So you get here. Factor. No C shit. Math, Tourette's.
And then with the x squared that you get, you do the quadratic formula.
Siri? What do you think? I'm sorry, I don't like that. Screw you, Siri. That'll be on the iPhone 7.
Really? There is that sometimes?
There's an app you can download that you just point it at a math problem, it'll do it for you.
What?
What is it called?
Like,
Is it like a math?
It's called,
solver?
It doesn't do very advanced problems yet.
Okay, just give
it's called,
It's getting there.
hold on.
I can't remember what it's called. I can't remember what it's called.
I think it's right.
What's that?
I said sooner.
Yeah, I know. Yeah, so you ever seen Wall-E? We're basically headed there.
What?
These
Yeah.
big fat people that have no idea about anything, just floating around watching stupid
Such
TV.
a sad.
We're not too far away from there right now.
But I love that movie.
It's called
though.
Why Homework.
Wall-E, yeah.
Why
So we
Homework?
give money.
What is it?
Why Homework? It's homework for people like the why.
But that's the app that you can point your camera at it and it'll do it for you.
That's what my daughter's got around.
Wow.
And then she's with high school teacher.
So the big dude was the one.
Alright, so here we go.
So that's the problem.
Don't get excited. It can only do it if it's written. You can't do it for handwritten. Right? So then you can just point it, and it can't do anything more advanced than something like, I think like x plus 7 equals 11 or something.
Oh, so I don't have it, but it's photo math. That's what it is.
That's photo math. Yeah, exactly.
Yeah.
Oh yeah, you know somebody that
I know a guy who knows a guy.
that knows me, and I got it. So what goes? So this will be x x x. This will be 3 3 3. So what goes in the little dude?
X minus 3.
1x minus 1 3. So
X squared plus 3x plus 3x.
3x
good. Plus 3x plus 9. So here's where you get your x equals 3, and then here you can do what?
quadratic.
Quadratic formula. Do it. Because you can never factor the big dude, so the big dude requires quadratic formula to be done. So do it.
So, because I got negative.
Yeah, you're going to get complex numbers.
Okay.
You can break that up.
And then you can break it in two, like positive and negative. Because I don't know, I'm trying to remember from school. When you were able to do minus 3 plus whatever was that?
Yeah. So whenever you have that plus or minus, you actually have two answers. Negative 3 plus that over 2, negative 3 minus that over 2. Yeah.
Do you understand what he said?
No. I don't have a clue. He's saying old bird. I have a clue saying. There's an old bird. He's an ornithology class. Yes.
Is B supposed to be 6?
No. Yeah, the big dude for cubes is this times this. It's always half of what it would need to be factorable.
Oh, okay.
Yeah, you're thinking, but the big dude's never factorable. Yeah.
But Jeff, do we really have to memorize this stuff right here, like minus b plus minus b
Yes.
squared?
Oh, let me think.
Seriously, because I'm lost.
I did. Yes, I said you do, and you do.
Yeah.
Yep. Or you don't. You just, don't do that problem test.
Do we
Or there's
just
several
use the coefficient, right? We always use the coefficient like
Yes,
one.
exactly.
Yeah, so
A, B,
one,
and C are
three,
just
and 9.
numbers
Okay.
for us right now. You could actually use that.
So you're just plugging in those numbers that you gave us.
Yeah, those are the coefficients of that. So this has got to be in the right order, right? A is always in front of x squared. B is always in front of x. C is always, so they just move it around. Don't take the first thing you see. A is in front of the biggest degree term, so forth. So how does this come out? This will be
Minus 3, I guess minus 3 squared,
Minus 4.
36. I like it. 4 times 1 times 9, so minus 36.
So it's negative 26.
Two. Yeah, exactly. And we're not worried about that anymore at all, are we? You see a square root of a negative number, we don't freak. We just know it's going to involve an I. Good. So I get negative 3 plus or minus negative 27 all over 2. So how can I break down negative 27?
3i,
Not quite.
negative 1.
Oh, okay, gotcha.
Negative 1.
So this will be square root of negative 1, square root of
Yeah, wow.
9, square root of 3. So that's how I can break it up if you want to. Right? Because 27 can be broken up as 9 and 3. Why would I do that? Because 9, I can do the square root of 9. Right? So I have to simplify the radicals whenever I can.
What happened to, I'm sure what you did with that too was on the other.
I'm finished right now. Yeah. My bad.
Okay.
Let's make a point about that last piece. And then we get negative 3 plus or minus I.
3.
So I get 3i square root of 3 all over 2. And will 2 go into anything? No, so I can stop it.
If it wouldn't be a number that could go into it, we will have to.
Yeah. If it was a 6, I could then break it up and reduce it.
This requires simplify everything.
Do. Yeah. Alright.
So what about that, x equals 3 we did over there?
Yeah, so that's one answer, and then those are the other two.
Oh,
So how many total answers do I have?
3.
3, right? Because this is negative 3 plus this, and negative 3 minus this. I mean, that plus or minus represents two separate answers. It's just that was a long time to write. So we only want to write it once with plus or minus in the middle. Right?
So this is.
And real quick, how are these related? These complex numbers, how are they related?
They are conjugates.
They are conjugates. They will always be. If there's any complex solution to some equation that only has real numbers in it, they will show up as conjugates of each other. See how slow I talk there? When I do that normally, it's a good note. Whenever you have complex answers to a polynomial equation like this, with real numbers, they got to be conjugates. So I can never show up on its own. There also has to be negative I somewhere to be a conjugate pair, right? They don't go anywhere by themselves. They always have it's a buddy system.
So the third answer would be x equals 3?
Yes, so there's one answer there from the beginning.
Yeah, that's true.
And then the other two took a little bit more work. I like it. And since they were imaginary, they were complex, they showed up as a conjugate pair. Yes, ma'am.
Can you write that 9 minus 36 as the other answer?
Sorry.
9 minus 36?
Yes, that's negative 27.
So, no, can we write that answer? So, can we just like get it as the same as that answer, like the other one? So, can we get it just like minus 3 I? No, she's saying skipping all those processes. If you know from that point, can you just write negative?
No.
No.
I don't know how you would know.
How are you gonna know it? I don't remember.
Okay, I can do that. I'm sorry, I don't know what you're trying to say.
I'll just solve it and show it to you.
Good, thank you. Because maybe you got a new way to do it. I like it. All right. So that section 13.2 is all about quadratic formula. Let's see if they give you a certain kind of problem. No, they don't. Those dorks, all right. Blah, 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 blah. Okay. So, I mean, at the heart of this, if you can figure out those quadratic formulas, then you just plug and chug, right? Not a big deal. Yes?
So you got the I from the -1? The square root of the -1?
Exactly.
Okay.
Yeah. Let's see. So the only thing that they could do to you is something like this here. You say solve that.
Wait, you actually want us to solve that?
So if they say solve this, what would you do?
Well, you distribute
Yeah,
everything.
you want to try to get it. You know it's going to have x squares running around in it, right? So you want to try to get it into the right form, something x squared plus something x plus something. So you know what A, B, and C are. I mean, so they can start off with this completely not organized. And all you do is take a minute and FOIL this bad boy out, distribute this through, get your like terms together, suck the 11 over, right? Get it equal to 0. Does that make sense? So there are a couple problems like that in the homework. You just take a minute and just do what you can do, get all your like terms together, make it look like ax squared plus bx plus c, and then you know what A, B, and C are. So I'm just showing you, that's the worst they could do to you for a quadratic problem. It's just have it all splayed out everywhere. Right? You just got to collect it all back together. Does that make sense? So to just do this, you know, you FOIL this bad boy out, take the -2 through, then get your x squares together. I can bring a negative in. You guys kind of with me? And then get your like terms together, right? Is that cool? So that wasn't that big of a step. I just FOILed that bad boy, brought the -2 through, right? You're looking at me like I'm doing. Now I'm starting to do ancient history class or something, right? What happened in that? So FOIL it out, not a big deal. Bring the -3, get your like terms together. Right? Make it look like this. If you can make it look like this, you can do quadratic formula. Right? Now I hope to God that if they gave you this and they said solve this, you would not use quadratic formula. In that case, it's way too much work. Why is it way too much work here? You can factor it, yeah. Right? How does this factor? You don't want to kill the middle term, you want it to be there.
Sorry, yes.
You gotta apologize to the middle term span. It's trying to kill him. Not Danny. Sorry. So is that cool? Oh my God! Can you imagine the quadratic? What that would look like?
But wouldn't it have only
We got that
two
x squared plus
answers? No.
Yeah, we do. We do. I like that. I love it. We do have two answers. They just both happen to be the same thing. So in pre-calculus, we call this. It's got multiplicity 2. It shows up twice, right? I always think about that movie, Michael Keaton, Multiplicity, if you ever saw it. But multiplicity 2 meaning it shows up twice. So you're right, it's got to have 2 answers, doesn't it? And it does, they just both happen to be -2. So it does have 2 answers, yeah.
So if you have like a problem like this, like ax squared plus bx plus c equals 0, then you try to factor it, and the factors, and you use the quadratic formula.
I love it. There you go. There you go. Cool. And let's try something real quick, and then we'll do. I want to.
This is section
13.2. Yeah. We're going to do 13.7, but then we're not. I'm going to make 13.8 extra credit, if that's all right.
Yeah.
I thought that might be. So real quick, I just want to show you something.
So is that still 13.2?
Sorry, just 1 minute. No, I lost the motion.
I have a question.
Yeah.
You were saying that 13.3 is the same, but we don't have to do it, right?
From the beginning, we didn't have it. If you look at the syllabus, it's 13.1, 13.2.
So the one that you were
13.7,
saying
13.8.
that the problems might be like distribute, that was about 13.7? No?
We haven't gotten to 13.7 yet.
Oh, okay.
Yeah.
So
13.2.
switching between 13.7 was extra credit, you're just doing it to 13.8.
13.7 we're going to do.
Yeah, but
13.8 is extra credit. Yeah.
Just switching.
Okay. This is factored, right? So how do you factor this?
X plus 10, x minus 2.
Yes, right? So then you should get
X equals 10 minus 10, x equals
now, quadratic formula will still work. Quadratic formula always works. So let's see what quadratic formula looks like for this. What's A, B, C?
1, 8 minus 20.
I like it. Cool. So then you get negative B plus or minus root B squared minus 4AC. So negative 4 times negative 20 is plus 80. Is that cool so far? All over twice A. So whenever you start to do quadratic formula and you end up with something like this, then it's quadratic formula is something you could have just factored the damn thing. So if you end up with rational answers, then it was a factorable problem. Right? But it's not a big deal. If you just couldn't see that it was factorable and you honestly just did quadratic because you didn't think it was factorable, then this will tell you, oh yeah, it was factorable, all right?
And if we do something like that on the test, would it be marked wrong?
No, I mean, I'm going to have places where I'm going to ask you directly to use quadratic formulas, so that's where I'm going to be where I can make sure you can do it. Or to factor, I'm going to say solve by factor. So there's negative 8 plus or minus 12 over 2. So I get negative 8 plus 12 over 2, and I get negative 8 minus 12 over 2. This is one reason why I wanted to do this. Is to really show you, here I have to break them up. Because I can't do negative 8 plus or minus. I love when it's, where's the plus or minus key? No. What's negative 8 plus 12? 4 over 2 is 2. And then what's negative 8 minus 12?
Negative 20 over negative 10.
Negative 10. Alright, right? But dear God, right? Versus. Alright. So, I want to connect this with what's going on graphically. What? So. Alright, so I want to graph this. Let's see what this is going to look like. So, most of us should know what this looks like, but let's pretend we
Isn't
don't.
x squared parabola?
Yes. Good. So if I make an XY table, if I don't know what something looks like, I use equal amounts of negative and positive inputs just to make sure I capture all the weirdness it's trying to do. So what do I get if I put a negative 2 in?
4 raised to 2.
I get 2. Yeah. Negative 1. be 1 minus 2, negative 1. 0 would just be negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. Do you see how it kind of goes down and then comes back up? Right? So when you graph this, it does have that shape that most of you should know. So at negative 2 it's 2. At negative 1 it's negative 1. At 0 it's negative 2. At 1 it's negative 1. At 2 it's 2. It's got this U shape to it, right? This parabola. Otherwise known as parabola. Alright, so if, this parabola, depending on what I do with my equation, it could move around. Right? So this is normally sitting here, but I did minus 2, so it went down 2, see? If I would have put plus 2, it would have been up here, opening up. How many x-intercepts does this have?
How many what?
X-intercepts. 2. You can see them. I'm not asking you to find them, I'm just asking you how many there are, right? What's the most important point besides x-intercepts on this graph?
The center.
The center. The turning point, right? So we have to develop a way to figure it out. So if this was a model of the cost associated with building something, where would I want to be? If I'm the one trying to build this thing, I'd want to be here, because that would be the least cost. You with me? Mm-hmm. So when you talk about maximizing profit, so here's the profit. I want to be here because that's the most profit I can make. So that's why that turning point is the most important point most of the time on a parabola, because that's where interesting things could happen. That's the biggest or the smallest, depending on if it opens up or opens down. Okay, cool. So this would open up because this was positive here. If I would have made it 2 minus x squared, it would have been like this. It would have opened down. Cool. And then it would have had a maximum, kick ass. So what I'm interested in is to come up with a way to find that vertex is what it's called, the max or min. So this is called the vertex. So a general way to find that vertex, no matter how ugly the equation is. This is a relatively nice equation, right? There's no middle term to mess me up. Okay. So here's where things get fun. So completing the square suddenly comes back. He's got something to do. Do you guys get that? If I would have had it just be this, at 0 it would have been a 0. It would have looked like this instead. But the minus 2, what did it do to it? It just moved it down 2. Right? So let's try one more with the table. Try this one. And let me give you the values to use because it gets a little freaky. You can do it, Jeff. Can I? No, I can't. Let me try again. I asked. That should be enough. What's negative 4 plus 3? Squared? 1. Negative 3 plus 3?
0.
Squared is 0. Negative 2 plus 3? 1. Squared is 1. Negative 1 plus 3?
2.
Squared?
2.
I like that though. I should follow it, but no, it's 2. So let's see what this thing looks like here. So the most important point is the turning point, and as long as I capture that point, I'm good. I need to find out where that turning point is. So this is interesting. At negative 3, this thing is 0. At negative 4, it's 1. At -2, it's 1 again. So that is my turning point there, right? And at -1, it's 4. So now this thing looks like that. So normally it's like this here. So what happened to this? It moved
-4.
back 1, 2, 3. Right? And do you see how all my inputs, if the first thing I do is add 3 to the number I put in, the number I put in can be 3 smaller than it was before. Let me say that again. If the first thing I do is add 3 to the numbers I plug in, they can all be 3 smaller than they were before. So how did I get 0 here? What would you plug in to get 0? 0. That's crazy. So x equals 0 gives you 0. How do I get 0 here? What do I plug in to get 0? -3. Holy shit. So it had to be 3 smaller than it was before, because the first thing I do is add 3 to it. That's why the whole thing went back 3. Interesting. So we're not going to get too deep in the idea of shifts, but explaining how to find the vertex makes more sense. When it's inside with the x, it does the opposite of what this is. +3, but it actually went back 3. When it's outside, it does exactly what it says. It's -2, it went down 2. Right, so because it takes all the old outputs, it makes them 2 less than they were. That's what the whole thing shifted down to. So here's the nice thing. Let me see if you guys are with this. So normally the vertex for x squared is 0, 0, right? So if I can just figure out, if they give me something like this, I can figure out where the vertex is. Because I can see how this thing is moved.
It's going up 4.
Yeah, it goes up 4, so the y piece will be 4. And the x piece, how do you get 0 now? You plug in a 1. So the vertex would be at 1, 4. Let's do another one. So if I had y equals, what you got, Jeff? X plus 4 squared minus 7. Where's the vertex going to be? Yeah, the opposite of this. So -7 is the y, and the x is going to be -4. So it starts at 0, 0, but this is going to move it back 4, and that's going to move it down 7. So now definitely, right? Because of what happened here. Where's this guy's vertex?
0, 0.
Where's his vertex?
0,
-3, 0. And what was it in here? What did it say? It said +3. So if I see it's a minus in there, and really all you got to think of is what would make that 0. 1 would make the 0, that's where you are. Right? And then what would make this 0 is -4. Yeah. And think about, let me see. Since this opens up, I know this opens up because it's positive here, right? If I put a -2 here, something would open down. So since it's opened up, is this going to be a max or a min if it opens up?
A minimum.
It's going to be a minimum. What's the smallest? Let me see if some of you guys are with me. The smallest value this could possibly have, if this is any number other than 0 inside, if that squared is anything other than 0, this is going to be bigger than 4. But if this is 0, isn't the answer 4? So what makes it 0? 1. Even if I put negative stuff in, I'm squaring it. So then it becomes positive, added to 4 is bigger. So how do I find the smallest thing? I make this the smallest it could be. And what's the smallest anything squared could be is 0. So how do you make it 0? 1. How do you make it 0? -4. Right? And then this just tells you exactly how much you moved up or down. So that's going to be the y piece. So this parabola would look like 1 over and 4 up. And then it's going to open up from there. And this parabola would be 4 back and 7 down. And then it's going to open up from there. Okay. So if I could put my function in this form, I can just read off exactly what the vertex is. Right? If I could put it in a form, I can just look at it and tell you what the vertex is.
Oh,
Oh, okay.
So it's sort of like mx plus b. If I put a line in that form, I can just look at it and tell what the slope and the y-intercept is. So this kind of goes through all of math. If I put a circle in its form, I can tell you what the radius is, right, and where the center is. That's a general idea of mathematics. If I put it in a certain form, I can just tell you what certain things are. And not just me, anybody. So, of course, they're going to give us one that looks like this. And is that in that form? No. All right, so here's where we got to do a little Indiana Jones. You'll see what I mean in a minute. If you don't like Indiana Jones, it's too damn bad. How do you think we're going to make this happen? What process do we have that makes that kind of thing happen? Sort of. Completing the square, exactly. Right? I kind of gave that away earlier, so it's going to come back into play. So I want to make a little room, but how many sides can I work with? 1. So I just have to move the 11 over a little bit. So I'm still going to make a little room here, right? Because what are my 2 steps? And then I got to know what to put there, so forth, right? Okay, so what's my 2 steps?
X divided by 2.
Yeah, the middle coefficient divided by 2. So -3. So what does that 9 do? Now watch, if I add 9, I better at the same time... Here's where Indiana Jones comes in. If I put the bag of sand on there, at the same time I better take the thing away. So if I add 9, I better subtract 9 at the same time. So overall, what did I just do?
But you should start putting this side or to the y?
What's that? I love that. That's exactly beautiful. I love it. So we just did nothing. Right? Not really. We just made this look a little different. What can I do with this piece now? Because I know where I'm trying to go. And this is why everything's on that side, isn't it? So this factor is like what? X minus 3 squared. And what do I end up out here?
-2.
So what's the vertex?
3.
There you go. Sweet there.
Oh, wow.
So that's the Indiana Jones thing. He takes the thing away, but he better at the same time add something. And of course, he did it wrong. He can't balance his equation. Boulder comes down and squares. If you haven't seen the movie, what the hell? I don't care. It was made in the 80s. They still make good movies. They made the best movies in the 80s. So screw that. Yes.
I was just curious when
It's a good
there's
decade.
that when you subtracted 9 from the 11.
If I add 9 to this side, I have to subtract 9 at the same time. So that's why it's legal.
Because I'm saying, or it used to be where it was, and how you showed it before. It's on the slide with the.
Yeah, now watch. Now. Okay, so watch. Watch.
It looks to me like the y is the other side because that's where the equal sign is.
So technically, I always wait till somebody asks me this, but technically, I don't like doing this because it's not really, no, it's not there yet. So here's the plus 11. All right, that's before we did anything, right? So if you did add 9 here and add 9 there, you don't want y plus 9, you want y. So what would you do? You would subtract 9, wouldn't you? All right. I mean, that's... So instead of putting it over and then bringing it back, just freaking do it.
But can we do that with the others too?
What do you mean?
Like, okay, the other ones.
You are doing nothing.
Yeah, the other ones are different because I had 2 sides of an equation to work with. So I could do the same thing to both sides. This is not really an equation. This is a function. Right? I could even have f of x here, right? Okay.
But doesn't the equal sign make it an equation?
No, it's a definition. It's what f is defined to be.
Oh, not the x then when you have.
Even y. It's what's y defined to be. Yeah. Cool. It's not really an equation. I can't solve it. But I can't analyze it. I can see where its vertexes and stuff like that. So, thankfully, everybody's watching the clock. Very quickly.
We're brain dead.
Very quickly. There is a shortcut to this, thank God. There almost always is. Not always. You gotta be careful. There's not always a shortcut when there's a completing square, but in this case there is a shortcut. Can you tell me, if I have a vertex and I know where its x-intercepts are, can anybody tell me where the vertex must be in relation to those intercepts?
In the middle.
Why? Because the parabola is symmetric. Boogie woogie, right? So vertex would have to be, so my intercepts were 3 and 5. The vertex has to have x equal to 4. Right? So let's do one problem real quick, and then the next time we'll talk about how this works in general. So if I had something like this, let me just do what we just did. What are the x-intercepts there?
3 and
5.
Yeah, 3 and 5, right? So I know the vertex has got to have an x of 4. It's got to be right in the middle of those. How do I figure out what its y piece is? Because the vertex is a point, right? How to figure out what the y piece is? Negative. 4 minus 3 is 1. 4 minus 5 is negative 1. 1 times negative 1 is negative 1. So it's a beautiful shortcut, is if you know the intercepts, you just take the thing in the middle, and that's where the vertex has to be. Now, the intercept's always looking nice? No. That's where we come up with an ultimate shortcut, which is your little cliffhanger for next time. And just to remind you guys, we do have a quiz. I think the last quiz didn't go as far as I gave it back to you guys, right?
Yes, you did.
All right, that's right. So this quiz is going to focus on complex numbers. What do you mean? Tuesday, yeah. It's going to focus on complex numbers. I don't know. I think I'll just focus on complex numbers. There's enough to do with complex numbers, I think, by themselves.
13.1.
Section, no. 13.1 is quadratic. Section 12.8.
Oh, 12A?
12.8. Yeah. Trust me, that's plenty. Right?
I was gonna say, there was a lot in 12.
Yeah, there's a lot there.
Hold on.
Oh, shoot.
So 12.6.
What's this for next time? What's up?
12.6.
I'm trying to-
That's what I was talking about.
12.8.
I thought we were going to put the third
No.
Oh, yeah. Just to write the answers?
Yeah, just
Yeah. Okay. I thought you were talking about a different way to figure it out. Yeah, you're fine. Yep.
12.8.
Now,
Oh, the whole
we're still looking
Oh, yeah.
so I think the newest